at JFrog in R&D team. I'm also core contributor and mentor of the CNCF incubating project Litmus Kiosk, where I have contributed to more than 10 repos and also co-owner of a couple of repos. And also feel free to ping me after this talk for the chess. I'm international rated chess player. So I have questions like how we deploy applications in nowadays, like any open things like anyone wanted to share an experience like how we actually deploy our applications?
We deploy our application using Jenkins CI/CD.
Okay. Any other?
So we are using AWS Code Pipeline. We are deploying the application to the ECS instance.
Okay.
And we can use, rather than ECS, we can use Beanstalk, EKS, and EC2 instance as well. And we can able to deploy the application to Linux or Windows servers. So there are lots of CI/CD tools like TeamCity, Octopus, Jenkins are available in the market. By using it, we can deploy the application based on our requirements.
Okay, nice, great. So, sorry, hello. Okay, so how we install application, like okay, I appreciate like and for the points like how we install, like you use Helm charts or
We using Helm charts.
sorry.
We are deploying using Helm charts.
Okay, any other? Okay, so I have a story. So 1 second, sorry.
Breakfast must be being delivered, maybe. Was that your breakfast?
Sorry.
Was that breakfast?
Okay, so I have a like question. So we all order pizzas, right? So let's take example. We order pizza at morning, afternoon, evening, late night. Is it correct to say like every time we get on time, or every time what we order in the like we get freshly? Is it necessary? No, I don't mean you should order. you don't order, like just for question. So what we can say that in morning when we order, or in the late night when we order, it can be like have the time difference, or sometimes it also happens that pizza itself not getting delivered for a long time, and we are still calling, hey, where is my pizza, where is my pizza, I'm hungry. So the point of thing is that, suppose just take example, we have ordered a pizza, because of some reasons chef has some issue or some health issue or something, and he went off, he has taken a leave, but we are still waiting, where is my pizza, I wanted my pizza. So it can be possible where we have ordered the pizza and it getting delay, or it is not getting delivered on time, and it's causing us trouble, right? So point to understand is the same way when we talk about the application deployment also, it has the different ways, it has different behaviors, it has a different concerns where we will be discussing about in this main talk. It will be mainly benefits, like to cover up the points. Like application deployment, the same thing I'm taking here is like what about our application deployment, when we deploy our application, is that behaves the same. Also there are so many things which does our applications current deployment covers those points. Like just take example that we have a application, we have deployed it, it's working correctly. After some time we come up with a new version which has some DB schema changes, and we wanted to upgrade a thing. So that time we are going to face troubles, like when it comes to for migrations, automations, validations, and many more things comes, it causes us troubles. Like, okay, we cannot directly upgrade in that case. So we have to ready for to face the problems. So benefits of the today's presentation is like we'll be mainly discussing about the more advanced, like more automated thing to deploy our applications, like using the Kubernetes operator. We will have a custom controller logic, and we will see the how custom controller logic is actually helping us to come up through the many problems in day-to-day deployment life cycle we are facing actually. So are you ready?
Yeah.
Okay,
I am.
thank you for the reply. So let's have a comparison like what we have seen. So if someone says that, okay, I have an application which is have a one stateful set resource, I need one service, I need a persistent volume, I need a claim for that. I don't require any complex logic for to deploy my application. It's simple. So yeah, obviously they can prefer the YAML file. Someone comes with, okay, I have some couple of resources and I have a couple of manifests where I have to use those for the deployment. Then customize is like good thing. Yeah, we can just patch our resources and we can install in single line command our application. But someone comes, no, I want some more features. I want some complex features, complex functionalities for our deployment. And for that, Helm comes. Like, yeah, Helm itself provides a library where we can actually write our custom logic where inside the helper function, and we can actually use that define functionalities. So yeah, then Helm comes. But let's take some more advanced, like, okay, advanced in the sense we want more automation in our deployment lifecycle. So just for example, recently what we have taken is our upgrade thing, migration thing, custom validations things. So then Helm also, like somewhere we have the limitations for Helm also. Here actually the role of the operator comes in, where we can actually write our own logic, whatever logic we wanted to write. It not only respect to specific things, we can have it for the expanded way. Like someone wants to have the application is running, so they want some due to some reasons we don't know, like, right, what pizza chef, like he has some health issue, he has gone and we are waiting for our pizza. So same thing in application, in production also, we can have some downfalls where we have to manually go and make up. So one more question for you guys, like, have you faced any application goes down in deployment develop production environment? Have you faced that? Someone has faced that application itself goes down in production?
Yes, yes.
So what you do at that point?
So there can be multiple scenarios. So if application is getting stopped constantly, then we might roll back the changes. Or if server goes down, then we might definitely contact to the server provider, the cloud provider. And if we have DR set up readily available, then we might switch from live to DR instantly.
Nice, thank you, Sham. So yeah, we face downfalls, we come up with some manual way, and we have, like, yeah, someone, suppose just example, I'm sleeping at 8 a.m. and suddenly I have a call that our application goes down. And because once application goes down anyway, like in production, our customer is going to face issue, and that is the point where we cannot go and our search our one by one line, like then millions of line code base, and we cannot go and like just search on what is the problem and all. That time we should be, at least we should know what is the exact fix for that. Or we should have some automation, which is actually once some downfall or something comes, we should have at least some automation, at least some logic for that, to verify that and to fix that out, instead of having a lot of manual work. Is this sounds good? So next thing is that operator thing, which in operator, in the application specific controller here, we can actually package our deploy, manage our applications. We can provide our extra functionalities also to have upgrade things and migrations and all things. So in this, like basically we are going to play with the Kubernetes APIs. What is the Kubernetes API? Kubernetes API, where we can actually have API calls to our Kubernetes resources to manage our application state, where resources are like deployment, stateful set, persistent volume, config map, secrets, and all. We will actually play with them using the Kubernetes API, where there are some libraries, Python, Golang, Java, and so many things. So we will have a Java Golang controller logic, where we will actually write a logic for the Kubernetes API to resources, where we will configure a logic in such a way that when it is a freshly we are deploying, that time it should create. When if it is already installed, that time it will be responsible for the managing the application. And basically when we talk about the operators things, it comes with like we will have a custom resource definition, custom resource. The main difference between the custom resource definition and custom resources is, let's take an example that we have a stateful set resource. Okay, so in that also we can see that there are some specific specifications, metadata, and some specs comes by default, right? If suppose there is service name, so we can provide that in string, right? So why we have to provide it in string only, and why is this couple of specs are provided, that why we can't add something else what we want in that? Because there is already a definition which is validating that resource, right? So same thing in operator, where we controller, they watch a resources like custom definition resource, which is the definition of our new resource. Now whatever we are going to talk in the operator, we will have our own resource now. Like instead of like example resources are like pods, stateful set, and secrets and all, but now we will have our own resource now. So for that resource we will have a definition also. So what definition do, once we get our custom resource definition, and we are ready with our definition, once we apply that, it actually creates an API for our custom resources. So once we are done with definition, we can actually create our own resource object. So we will be mainly creating our object, and we will play with our resource object. For the timing, any question, and feel free to stop me for any like question or some. Is it good?
Yeah.
Thank you. So let's understand actually the working of controllers. So we all know that like we apply our some manifest. Let's take an example. Deployment is there. We applied kubectl apply -f our deployment manifest.yaml. What exactly it is doing? Can someone tell me?
Sorry, I haven't used.
Okay, so basically suppose we have a manifest which consists some resources deployment or something. So first thing we have to apply that, right? We do kubectl apply, right? Or someone is using, they will do Helm, they will do the Helm install something, right? So what is the first step? What happens like once we install the application, once we run that command? So basically Kubernetes also internally uses TLS encryptions. So you will say now, okay, I'm applying some kubectl apply -f deployment.yaml. It has actually created, it didn't ask me for JWT token or some validation. Basically when we apply or run some commands, you might have seen there is a .kube/config file is there, right? Hello.
Yes.
Yeah. So what that file contains actually, users, context, and all, right? So that file is exactly which is used for the validation. So once we install some manifest, it actually verifies with that config file. Once it verified, once it request is verified, it sends a request to API server, right? And API server talks with the etcd server, and whatever the new manifest we have created, deployment or some resource, it actually adds that in etcd database. There is what our controllers game start, like what controllers do. Controllers keep on watching against that etcd database. Some event occur there, it keep on watching. Some event occur there, it reconciles. It's similar type of stuff happens in other resources also. Let's take example. We all are aware about the replica sets, right? What replica sets do, it is responsible for the respective pods, right? And how it is specifically responsible, it attaches the owner reference. So I have 3 pods, I have to take care of this. If something goes down, I have to take new pod. If someone deletes, I have to take new pod. I have to create, and like, okay, why, how the controller replica sets coming to us to know that, okay, I have to do this, like how that how some pod deletes, how it creates again something. So it keep on watching against the etcd database. It has the, if some new event occur surrounded there, it reconciles. So its act, it observes any different pound, it reconciles. So what reconciles defines here, so we will have the same logic. We will have like not exactly same of the replica set. We will have logic for our resources, how our resource will work. So just for example, now what we have, like whatever we will be going to talk, it's like for our own resource, right? So for, if we are talking about the own resource, then we need our own configurations also. Suppose we have a resource like potato here. In demo we will take more into that. So resource of potato, now I want like how to our own logic for our potato, okay, our own resource. Same like what replica set is responsible managing pods. So what our resource is going to do, that is where we have to write in our reconcile logic. Any questions, Tembing? Okay, so for the demo, I have taken the operator SDK. It is from the operator framework, which is a CNCF incubating project. So we will discuss more about the operator SDK also, and selection also. Like there are others operators SDKs also, Cube Builder and all. So basically Cube Builder is also integrating with the operator SDK, like operator framework. There a couple of PRs got merged, like having the adding the resource like permissions and all, where we can define in our code base, and that will get reflected in our generated config manifest. So there are many things which have the advance with the operator SDK. So we can take, like we can think about the good flexibility. We can automate to whatever our needs is there. We can easy to achieve our compatibility and improve our consistency as well. So it also has the many features, admission webhooks where validation of the certs happens, and so many other features which operator SDK provides. So some time back, we were discussing about some downfall gone, like in production we do so a lot of things. So actually that all things, like we can actually configure in our logic. We can actually write a logic for that in some checks or some validations. If something, it keep on having checks like some a region, available region or not. So if something goes down, like it will have connect to other region, any type of sort of logic we can actually write inside this using Golang, and that will help us to have our application resiliency also. So we can also focus on resiliency also with operators actually. And it has also other features, like we can have include our E2E testing frameworks, end-to-end testings, and like we can add the BDD tests and all. So is it okay? Can we have question in it? When the next thing is that whenever we discuss something new to implement or new to add it, is it actually covers all Kubernetes distributions? Someone say that we have a customers which uses GK, EKS, Azure Kubernetes engine, or someone says like our customers uses the K3s Minikube kind. Or so is it actually it will run on those distributions? Yeah, wherever the Kubernetes can run, operator framework says wherever the Kubernetes can run, it will run everywhere. Like it might be a cases where we have to support, we have to support the multi-arc or some architecture specific things happens, so we have to give support, but that is a different thing. But yeah, on every distribution it will work. So this is the level of the Kubernetes operators, what it exactly does. It can be a basic installation, it can be a seamless upgrades, life cycle things, deep insight, and autopilot. Exactly where I was talking about some downfall happens. It will automatically configure the stuff, and it will automatically keep our applications up in production. So first two things has been covered by Helm anyway. And like, yeah, Ansible and Go, they provide. So in this our presentation, we will talk more about the Golang based operator. Any questions, guys? Okay, so now coming towards the implementation part, and very important thing is that whenever the operator comes up, we kind of get stuck into the permissions things. We will also discuss about the operators like permissions, what permission, and how to tackle with them also. That will also cover. So implementation is where we will have like reconcile logic, where we have to add our configurations, we have to add our logic there, and that logic can have like, that can actually solve our many complex problems. Like in starting, as we have discussed, some current version is there, we have installed that, and some new versions comes up where actually the schema has been changed, and we have to make upgrade on the top of that, it will fail. So we can actually write a logic to make these steps like internally only, so we don't have to do any manually migration or something. We don't have to worry about like manual things. It can automatically handled by our Kubernetes controller side only. So is it sounds good?
Yes, yes.
Yeah. So here we can actually simulate our failures also in all part of our cluster to test its resiliency. It can also, we can also move on, focus on our resiliency also with this. So you will say that, okay, we have a chaos engineering for the applications resiliency. But one more point there, when we do a chaos engineering, we actually have a virtual environment where some failures happens. We get to know that, okay, this application is going down. But at the end, we need a proper solution for that, right? Chaos engineering what else to have application resilient with some solution, right? So we have to configure that solution. So that can be possible with the operator thing. And we can have a better matrices also. Operator also provides the matrices where we can actually have a visualization for those application matrices, which is provided by the operator only, with the endpoint metrics, where we can have that matrix and we can actually see our we can see actually our performance or applications, how the resources has been used, CPU, memory, and all. It will help us. And for the permission thing, of what you think, like suppose some application is coming, some at the end operator will run, controller logic will run inside a container, right? They need some permissions. Let's talk first about the controllers, operators, pods permissions. What you suggest, like, is it should be like cluster level or namespace scope? Like, what do you think, guys? Any idea?
No.
I
Okay,
think
so
it should be cluster level permissions.
okay, any other thing? Okay, let's take example two things. Okay, one is the cluster level, one is cluster scope, and one is the namespace scope. Now if we have a cluster scope, we have to provide a cluster level permissions, cluster role binding, cluster roles, right? If we have a namespace, we can provide role bindings, and we can provide actually namespace scope where we in cluster level operator can actually scope the cluster, and in namespace actually operator can scope the namespace only. So here, which one will have a larger number of permissions, cluster or namespace? It's obviously cluster, right? So it's first thing, it's completely depend on our use cases. If someone wanted to write a logic for cluster scope, then it's okay, they can have a cluster scope and they can use that with the cluster scope permissions. Someone is having use case of deploying applications and managing to a namespace scope, then they can have a namespace scope only. But still, when the operator comes up, it's according to the standards to have a minimum permissions for any container. And it's better to use the namespace scope because it will have a lesser permissions, and it's the standard way to keep minimum permissions, and it's good way to handle the operator to namespace scope only. So let's take more discussion in demo. Are you ready?
Yes.
My screen is visible?
Yeah.
Okay, let me take you to a couple of things first before actually installing it. I already there are few commands to generate those, okay, to generate some basic stuff which we get from the operator SDK thing that already I have generated. And after that, the main thing, how the flow goes, basically it's first thing is that actually basically we have a main file where we have to register our controller here. So first thing is to set up with the manager our controller so that controller can know. And during the setting up, we have to set up two things. One is the for and one is the owns, where controller will actually owns the resources, and one is the for, where we have to keep watch. So any from those things, one is the for whom they have to have a watch, and other is the owners. During this what other resources we are going to play with, to own those resources. Any one of any changes happens in any one of the resource, it will reconcile. Okay. And the primary, since we are used control logic to have the configurations. So basically it will mainly, we will talk about the potato head. It's a sample resource we have created where when anything changes in this for, it reconciles. And what exactly reconciles is our logic which keep eyes on the events. Any event happen, this function will run. So let's start some event occur, and here we have the configurations of that. One is actually if all, for the demo purpose, I have only created two functionalities. One is the create, which is actually responsible for creating all the supportive resources, deployment services, and all the supportive resources. If it is actually created, it will manage. If something got okay, we all got that some happens in our actual resource, this will reconcile. So if this will reconcile means something changes, right? In desired state, something changed. So we have to match that with the actual state, and we have to update our state, right? Current state. So for that, we have a manage function. So basically it will keep eyes on our resource. Anything updated in our custom resource, it will go and it will update our other resources like stateful set, service, persistent volume, and wherever the respective resources are there. So first thing here is the API, where we actually defines our definition of this thing. So we can see that in other resources, stateful set, for example, we can see that there is a specs, there is a metadata, there is a status and all. So same thing we are defining for our own resource now. So this is a potato head. Potato head is a open source project, which is from the CNCF only.
Boom, your screen is not actually showing the demo. It's still showing demo time. So if you're showing that, it's not sharing on the screen. I'm sorry.
Oh, sorry.
I think it was showing earlier presentation PPT only. Not yet started here.
Okay, I really sorry for that. Okay, now is this visible?
Perfect.
Yep.
Okay, so let me take from start. So basically this is the main file where some default configurations got generated from operator SDK. Okay, so generated, there are we can have the basic, this all stuff we can generate from CLI operator SDK. So that is a different thing. We will mainly focus on implementation and demo. So here some in the main logic, we have to add our controller, right? Okay, some resource we are going to add, we have to add the setup, we have to set that controller with the manager so that it can actually watch against the events and it can actually perform the reconcile logic and our configurations. So to set up with our manager controllers operators, so there are two main things comes in the role. Okay, one is the for and one is the own. So for is actually where we are going to have the for is actually which is a resource where this controller will have a watch. Okay, and owns are the actual other resources where it is owning during that main resource. Suppose potato head is a resource which will create and manage like stateful set service deployment and other resources. So we have to add that in one. So basically this is owning this. Okay, and this is the actual reconcile logic which we are discussing about. So any event occur in our resource, it will reconcile. So in this we have to add our logic. So what, just for demo purpose, we have added the two logics. One is the create and one is the manage. One is create, basically if suppose fresh installation is there, we have to create all this stuff, right? All resources like service deployment stateful set, and if that is already created, we have to like manage that thing. Suppose in the operator thing, two things comes up. One is the actual state and one is the desired state. Suppose actual state is X and desired state is Y, which is we have in desired state in the manifest, we have updated few tags versions. Okay, and we have applied that. So in actual state also comes to get to in desired state, right? To manage that thing, to actually update our new resources, we can have the managed logic here where we are actually going and checking our new resource and existing thing. If it is not matching, we are updating the resource. So this here actually this is only for demo. We have added create to create and manage. We can add n number of logics here and we can have like all configurations here. So from where like this resource is getting created, the schema exactly where we have to write the schema in types like, okay, API v1 alpha 1, since it is like first initializer. So for example, in stateful set, we can have observed that there is a metadata, there is a specs configuration, right? There is a status and all. So same thing for our resource. Now we are defining that thing, right? Potato it is a kind now where they have the metadata and we have the specs also. Like let's see more in specs. So this is the specs for the resource. There are some commands, make generate, make manifest, which actually generates the manifest, which actually generates a deep copy of the type we are. Deep copy is basically having the verification of our object, like the schema object. And we get make manifest also for once we define this schema, we will have a definition CRD manifest once we run the make manifest command, say like command. So we can see our custom resource definition for our kind now, potato head. So this is the definition. Any question for the timing? There are two things possible. One is actually you are getting something, one is completely blank. So let me know, I will take. Okay, I will proceed further. We can add our own like own functionalities and all. We can create n number of folders. We can add there the things. Client is okay. So let's take example. As we discussed there, we talk about some Golang client. Okay, basically just for example, we wanted to update something in stateful set. We can have a Golang. We have a Golang library. We have a default client. We use that client to play with that resources. Like we can have update, delete, n number of like crowd operations there. But now we are creating our own resource only. So we can write our own client also for our resource register client. You may say like, oh, we can use the dynamic client and all. Yeah, we can use, but it's better. It's the standard way to write our own client for our own resource. So now let's see how the manifest is there. So this is our new resource kind. Okay, what our kind have the specifications like this. We have added some couple of keys here, specs here. So environment, couple of things here. And one question, you have gone through Helm installation, right? Some of.
No, I don't.
Okay, so anyone gone? Okay, so in Helm, we have one frustration. Okay, let me share with you. So in Helm, what happens? There is a values.yaml where we update and we install. Okay, while installing values.yaml have internally some helper functions which is taking keys from values.yaml and updating in the resources. So if we see any values.yaml Helm, there can be possible of thousands of line. Okay, in that we have used so many functions and all. So it is very frustrating in Helm to manage the value.yaml, and it will be very big. So with comparison to that, we can see here is that it is very less and it is very simple to read, right? We can have a single hour resources, which is very less, and most of things has been taken care internally only, our configurations only, functionalities. So, and we are ready with our CRD. CR is there, and this is the deployment for the operator. And this is the RBAC. Let's discuss more about the permissions now. So basically, when the RBAC comes, we all know that when we locally do, we have the access. We can, because of that, we can actually send a request. We can actually create some resources, delete some resources by doing some simple command. But this will run inside a container, right? We have to authorize the processes which are running inside the container to play with the Kubernetes API server, right? To play with that, we have to give some permissions also. So there is where like the RBAC roles comes in. You might have remember like in older days in the Kubernetes, like we used to have some node based control, right? Then attribute based permissions came. Then we have now RBAC, rollback access control. So which is why rollback is coming, because we have to authorize the process inside, right? We have to authorize our script also to create our all the functionality to perform our configurations. To make that, we have to authorize. We can authorize using the service account. Okay, and this service account is have some roles, and which is got binded by the role binding. So now this service account is bounded with the roles, with the given roles. And for now, I have given like most of resources and most of like permissions like here. So for example, resource is stateful set, and we have given wops, get, watch, list, create, delete, update. So inside the container, we can have a API call to stateful set, which can perform these many things. It can come create, update, delete, and that thing. So here permissions comes in the role. We can reduce here as much as possible. Like suppose, for example, let's take example of the secrets, right? Secrets is which holds the sensitive information. Suppose we give the permissions, it depends again. Just take example, if we give a permissions here like secrets, which can actually create, watch, list, delete, and anything. So somewhere in suppose customer is using and they have their own secrets, and our operator also have permissions to play with secret, then it can be a possible our operator itself is updating their secret, right? Since it is having a permission. So these things might affect, like we have to take care while we building the operator. And let's have now demo thing. First thing is that we have to apply our
Again, you are showing your results to be code, not the other session. Thank you.
sorry. Okay, I'm installing just the CRD definition. Now we have installed the definition. It is actually now we can create our own resource, okay, with of what definition we have. Now let's apply our RBACs also. Okay.
Sorry for interrupting you. Like, just want to know, before proceeding this, SDK operator, once we install, right, what are the default components that get installed? So you have,
Okay,
you have not explained that, and you have a little bit further.
sorry, will you please repeat your question?
Yeah, SDK operator once we deploy, right?
Huh?
So what are the default like components gets installed in it, and that you have not explained. So you are little bit ahead.
Okay, so basically you are saying inside our code base, right?
Yeah.
Okay, so this, you can see this main file, Docker, makefile, some hacks, bin. These folders get by defaultly created when we, and this API and controller folder. The folder structure is getting by defaultly created. Okay. Now, and by defaultly, this controller is getting created with the empty reconcile logic. Okay.
Okay.
And in API also it gets created with empty, like it's only some spec, this kind of, okay, it's some, most of things are empty, where we have to add our definition, add our configuration into this types. We can generate this, and we can generate the manifest also, where manifest, once we run the command make generate make manifest, this folder will get created, where all manifest will get created by defaultly only. The main thing is that now here, this logic, okay, suppose for create resources, now we have written this logic. Now we have written everything from this, like this, all the things we have to, now it will give only default template type. Basically it's the HDK development kit. Okay, so we will get some default kit. We, on the top of that, we have to write our own logics now. So create, logic, manage, we have written our own logic now. For this we need some extra functionalities, like some deployment schema, so we have written that thing. So on the top of default, we have to add our own. But if your question, like your question is like what all the things get by defaultly, we all get the directory structure here, where we have to add our new files and new functionalities.
Mhm. Okay, thank you.
Okay. Okay, so I have created a operator namespace. I have already applied the CRD basis since it is a cluster scope. Let me apply the, now which has been created, like the, these things are already there. Now it has created a service account for this. Now let's deploy our operator thing. Okay, operator deployment. Let's wait for that. Let's wait for some more time. It is running now. Yeah, we can see that it is actually having watch against our resource of kind. And let's install the let's install our resource now, the resource which we have created. So manifest like potato, right? Let's install that. Once we created our resources, it has reconciled. Okay, and it has triggered, like it has ran our all the functionalities, and we can see now here all new resources has been created now. It is having small Docker image size, so it has created very fastly. So we can see now it is having some version 0.1.1. okay, some, these all resources got created by the operator only, and operator itself is managing this. Just for example, now what I'm doing now, just I am applying our resource with the version. Okay, I'm just changing the resource and applying that. Let me apply this thing. I've just updated the version in the like. Let me describe you here. Let me fix it a little bit. Okay, so we have the own resource now, potato here. Now let's describe it. Okay, so we can see our current version is v 0.1.1. I have just updated manifest with this version and applying the new manifest. Okay, apply the configure. Now let me describe this thing potato again. Now version is our 0.1.1. Like basically we have our own resource now. By the simple one thing update in our CR custom resource, which is like having kind potato, we have to update there and we have to apply that thing. Once we apply that thing, reconcile will run, or like we will have a reconcile and it will update our new logics. Okay. So we can see now our new image is 0.1.0. You can see like this. Any question?
Like whenever a new version is there, we have to update manually or with respect to the auto update, whether we have any chance of version auto update instead of like manually doing the changes every time.
That's really a great question. Your answer is yes, we can have auto update. Whenever the new versions comes, or whenever we basically see, we have a logic, right? We have some Golang script. So whenever it comes to script, we can write their own logic. Whatever we wanted to write, we can implement their own logic. Okay. And that if something you want some update, some new versions comes up, we can set a flag there. If some new versions comes up, it's calling some API, something updates. We just have to update our own resource now. If anything we update in our own resource, that this functionality will get called. So this functionality will get called. We can write their own logic to update for migrations, for validations, for automations. So whatever we have to do, we can do actually with this.
Okay, auto update, if you do something like if it is not a stable version, in that scenario, it will be our application will be crashed. For example, that is
Yeah.
So, for example, like version 1.1 is an stable version. So we have upgraded to latest version 1.0. So consider that. So after the upgradation, there is an application crash. So
Okay.
in that scenario, how would we overcome that?
Okay, so let's take example like what we have seen here. We have updated the versions. Okay, now applications version has been updated. So instead of this, like we can have the auto update versions logic also, right? So in that, let's take example, some pod is crashing. Okay, some resources, CPU or some resources has been hooked, so it's crashing. So we can actually have the logic again to deal with that case. We can add our HPA, horizontal pod scaling. Either we can have resource or we can actually write a logic for that. So if something going down, we are having automation for that downfall. It's more on like writing logic now. It is giving us completely freedom. Whatever you wanted to write, we can write actually there.
Yes, thank you for your.
Is it sounds good? It's something good, something new and interesting.
Yeah, yes, obviously. So kind of make sure that high availability every time. The application there should be no downfall with respect to any kind of processes.
Yeah. It's more on like deployment. We can have the management also internal. It is healing, application is healing itself only. It can be a automation. We can have a lot of use cases for this, and it actually solves the complex problems. Like if some complex thing is there, it is which require very burden, and we can have, so it can actually solve that complex thing.
Okay, thank you.
And thank you. Feel free to connect me on Twitter, LinkedIn, GitHub, dev.to, and let me know if anything which I can help you. And thank you so much. Thank you, Ari, for this wonderful DevOps thing. and I'm
Yeah,
very glad and happy
thank
to
you,
be here.
Thank you for your
Thank
time.
you so much.
So I have some of the queries.
Yeah.
So actually, I'm new at the Kubernetes, so I haven't started implementing yet. But so what are the main use cases or more main features of the K8s that we should use it?
Okay, so first thing is like having getting known to Kubernetes cluster thing, all thing, how Kubernetes actually like helping. Because let's take example why we are coming towards the Kubernetes thing. Okay, so very basic things. We have the isolation container. We will say that like container isolation and all these things, but that got done by our VMs also, right? Actually the Kubernetes coming towards, we can actually specify our resources to our specific application. Okay, this application is there, we can have the resources for this. So first understand the basics of very basics, like where how Kubernetes getting started, how Kubernetes architecture. Once we are friendly with the Kubernetes architecture, then all these things, all the resources, all the stories will be very straightforward for you. And also know more about like Kubernetes clusters and distributions. That is the thing.
Okay, actually, just want to know whether you have written any blog with respect to the Kubernetes. So, kind of the complete over architecture in order to simplify. Do you have any such blogs from your end? You have
Thank you
written?
for Ali. I will write soon that blog. I have written many blogs, but not exactly on the Kubernetes architecture and all. But yeah, I will write soon.
It would also like so as you know, completely documentation of Kubernetes. It's a kind of lengthy. So
Yes.
kind of like if you share an overview for everyone, I think most probably it would be great and helpful for everyone.
By the way, Ari, we got a new idea for our new meetup. We can actually have understanding of Kubernetes. Yeah.
That's great.
Thank you.
Thank you.
So I have another query. So how should I start from the initial level for the Kubernetes?
There are some Udemy courses which I also went through. I will share you a link. Just ping me somewhere. Link in awesome. I will share a link with you. That will be helpful, because if documentation, lot of things in documentation. If you wanted to understand simply, instead of documentation, we cannot actually imagine our stories. So we need some visualization to understand. So it's better to have the course. And once we get the basic understanding from course, we can move with the documentation. But still from basic, just try to understand how the Kubernetes architecture is, basically flow of the Kubernetes. So if we have some time, I can take, but it's better like we can take next time sometime where.
For this, we are deploying to ECS, AWS ECS. So what else if we deploying to EKS? So is there any main difference if we deploy to EKS rather than ECS?
ECA is sorry, I'm not much out like what is ECA.
ECS is a Elastic Container Service
Oh,
and Elastic Kubernetes Service. So
I'm
do
not
you
more
know why we should use so rather than using Docker containerized application, so is there any reason to use or we should use EKS or Kubernetes?
I'm more into the Docker containerized applications, which actually help us to have the isolation of our application inside a container with the container networks, namespaces and all. ECS something where I need to look into. So, and EKS and all, basically it's like more on the engines where we can, it's a more on the distribution thing. We can actually deploy applications. So in my opinion, it's good all wherever you are using, but EKS and all things comes in the play, like it's more like advanced thing, in my opinion.
I think EKS is a software as service. I would like to say completely like end to end. You want to test something like with respect to the administrative part, with respect to deployment model, everything like a full managed. Then you can go ahead with the cluster setup completely.
Yeah.
You don't want to do the administration part, so you can go ahead with the software as a service. Backend, it will be supported by the cloud provider. If I'm right.
So you are in the JFrog and you have done some of the experiments. So which platform or cloud provider you have used for experiment?
For the JFrog, it's like confidential, I cannot say. But for the other things, like I'm in CNC projects and I'm day-to-day life, I use like EKS. And for locally, if I want to test, I use Minikube.
Okay.